We're going to be taking a look in this video at circles, specifically circles that are plotted on the coordinate plane. And we're going to be using some of the same ideas that we've talked about before when we're dealing with equations of geometric figures. We've talked before about equations of geometric figures like segments or lines, typically lines, and we're going to apply some of those same ideas to circles. So let's take a look. So back a ways, we talked about the equation of a line, right? And the equation of a line typically is written in the form y equals mx plus b. It was what we call slope-intercept form. And we would have a number for m and a number for b. So maybe an example would be an equation like y equals 2x plus 1. And so this line, this equation right here, describes how all the points that are on that line, there would be an infinite number of points that are on that line, and how their x and y coordinates are related to each other. So for instance, on this line, if you picked out a point and you looked at its x coordinate, so maybe it had an x coordinate of 1, then that y coordinate that would go here would be the 1 multiplied by 2 and then added 1 to it. So 2 times 1 is 2, and then 2 plus 1 would be 3. So the point 1 comma 3 would be on that line. If I looked at the point on this line that had an x coordinate of 2, then the y coordinate would be 5, because 2 times 2 plus 1 would be 4 plus 1 is 5. Right? So the equation of a line is a description of how the x coordinates and the y coordinates are related to each other. Another example of a line's equation, like maybe the most simplest one, would be the equation y equals x, where this line is all the points where the x and the y are the same. So 1 comma 1 would be on this, and 2 comma 2 and 3 comma 3 and so on, right, would all be points that are on this line right here, y equals x. So I just wanted to kind of refresh our memories about what an equation of an object means. It's just the description of how the points on that object are related. So circles that are plotted on the coordinate plane can be described with an equation. And when we were describing the equation of a line, we kind of needed to know two things about it. We needed to know its slope, and we needed to know its y-intercept, or where that line crossed over the y-axis. And once we knew those two characteristics of the line, it was pretty easy to write the equation. Well, for circles, there's two things that we need to know about it. We need to know where is its center, right? So its center would be at a location that we generically call h comma k. And we also need to know the radius of the circle, which we know is the distance from the center of the circle out to any point that's on it, right? So if I go from the center out to this point, that distance is the radius, or from the center out to this point, that should be the same distance, the radius. From here out to this point would be a radius. So if I know those two aspects of my circle, where its center is located and what its radius is, then I can write an equation by filling in those numbers, h, k, and r, into this template. So I'd say the quantity x minus h, or x minus the x coordinate of the center, quantity squared, plus y minus k, which is of course the y coordinate of the center, take that quantity squared, equals the radius distance squared. And that's how that's the template, or the formula, if you will, for how you would write the equation of a circle. So let's see if we can put that into practice a little bit. In this first example, we see a circle, and we have to write the equation. So the first thing I'm going to do is I'm going to write the template for this equation. The more times you write this, the more likely you are to remember it. It takes a while to kind of commit it to memory first. The first few times you're going to write it, you're going to have to look at your notes. But we have this quantity x minus h squared plus quantity y minus k squared equals r squared. And now I'm going to look at my picture, and I'm going to figure out the three numbers that are going to go in these places, h, k, and r. When I write my equation, x and y are going to stay as variables, but I'm going to put numbers in for h, k, and r. So as I look in this picture here, I see that it has a center at a, which is negative 1 comma 2, right? So my center is at negative 1 comma 2. That means that this negative 1 is going to be the value that I'm going to use for h. So this is h, and this 2 right here is the value I'm going to use for k. Now the next thing I need to figure out is what is the radius of my circle. What is the radius? Now this one, I can either just look at the picture and try and see from the center out to some point that's easy to determine maybe what the radius is, especially if I can just go straight to the side, either to the right or to the left or up or down, and figure out what that radius is. But sometimes it's going to be a little bit unclear. Like for instance, if I go straight over to the right, I can see I'm going 1, 2, 3, and then some portion of the next block, right? So this radius is like 3 point something, but I don't know exactly what it is. Thankfully, what I have here is I have a labeled point that's on that circle. And so what I can do is I can calculate this distance by using my distance formula for the center and for this random point 1, 5. So I'm going to find the length of segment AP is what I'm going to do next, right? To define my radius, I need to find the length of AP. So I'm going to use my big distance formula, which is the square root of the change in x squared plus the change in y squared. And these x's and y's I'm looking at are the coordinates for A and P. So I'm going to have the square root of the change in my x's. So A's x coordinate is -1 and B's is +1. That's a change of 2. So my delta x is going to be 2, and I'm going to square that. Now I'm going to look at the y coordinates. I have a 5 and a 2. That's a difference of 3, or a change of 3. So my delta y is going to be 3. So now this is the square root of 4 plus 9, which is the square root of 13. And if I type the square root of 13 in my calculator, I'm going to get something, like I said, it's something 3 point something. It turns into about 3.6, right? But I'm actually not going to use this rounded, I'm not going to use the rounded version of this radius. I'm going to leave it as the exact version, square root 13. Because what I see is I'm going to end up squaring that when I write my formula. And it's really easy to square a square root. We'll see what it's going to look like in just a second. So this is going to be where r is. And now I can go ahead and write my equation. I'm going to have x minus -1, right? This will say minus -1 squared plus y minus 2 squared equals the square root of 13 squared. Now I'm going to clean this up a little bit. Specifically, I'm going to clean up this part here because I have this minus negative that's kind of doesn't look like it normally does. And I want to have this part over here that I'm going to clean up. So first of all, my x minus -1 squared is going to turn into x plus 1 squared. The two minuses, the minus the negative, is going to turn into a plus. And nothing's going to happen here, so I'll still have y minus 2 squared. And then when I square the square root of 13, it just leaves me 13, because the squared and the square root kind of cancel each other out. So this right here is my equation. X plus 1 quantity squared plus y minus 2 quantity squared equals 13. In this example, we can just see we're going to write the equation of a circle, but we're not actually told any information. We kind of have to figure out some stuff for ourselves. So first of all, let's go ahead and write our formula for the equation of a circle. It's x minus h squared plus y minus k squared equals r squared, where the center of my circle is h comma k. Well, what is the center of my circle in this picture? What is this point right here? That would be -3, -1. All right, so this point is -3, -1. So the h value is going to be -3, and the k value is going to be -1. So when I go to write my equation, that -3 is going to go there, that -1 is going to go there. The next thing I need to do is figure out what the radius is. Well, I'm going to use the 2 points that they kind of have highlighted here, the center, and then this point right here, which it looks to me is -4, -4, and I'm going to find the distance between those 2 points, right? So I'm going to do the square root of the change in x squared plus the change in y squared. So this is going to be the square root of, let's see, our change in x, it's A -3 and a -4 are my two x coordinates. Those are only different by 1, so I'll have 1 squared for my change of x squared. Now my y coordinates are -1 and -4. That's a change in 3. So this is going to be a 3 squared here. So this is the square root of 1 plus 9, which is the square root of 10. That's the radius. So now I have everything I need. I have the center coordinates and I have the radius, so I can plug numbers in here, here, and here for my formula. And my equation will say x minus -3, which I'll write as plus 3, right? Since this was, since this h right here is a negative number, when I subtract that negative number, it becomes plus 3. So I get x plus 3 squared plus y plus 1 squared. It happens again because I'm subtracting -1, so it's going to turn into plus 1, equals the square root of 10 squared. So now I can clean up that r squared part. I'll have x plus 3 squared plus y plus 1 squared equals 10. And again, it's 10 because this squared and this square root cancel each other out. Careful not to put 10 squared here, right? That squared is going away when it takes off, essentially, the square root from the 10. So I just have the number 10 right there. Now in this question here, it's a little bit different. It says that circle Q has a radius of 7 and is centered at the origin. Let's just remind ourselves what that means. It means that its center would be 0, 0. Does the point -3 root 2, 5 lie on circle Q? So to answer this question, what we're first going to do is we're going to write the equation of this circle. So we're going to use our kind of template for the equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. And the 0 and the 0 here are going to be h and k. So something interesting is going to happen. This, of course, is going to be r right there. Let's go ahead and write this equation. We're going to have x minus 0 squared plus y minus 0 squared equals 7 squared. Now, x minus 0 is just x. So if I just have x in parentheses squared, I'm just going to write it as x squared, right? Because x minus 0 just gives me x, and then x squared is x squared. So this will be y squared, and this will be 49. So that's my equation of this circle that they're describing. Now, to figure out if this point is on it, all I need to do is take this number here, -3 root 2, substitute it in for x. Take this number, substitute it in for y, and check to see if this equation ends up being true. Because every point that is actually on that circle should fit into this equation. When I take its x-coordinate squared and I take its y-coordinate squared, I should get 49. So let's check it. Let's put this in for x and this in for y and see if it ends up being true. So I'm going to have -3 root 2 squared plus 5 squared. Does it equal 49? So let's simplify this right side first. Well, the 5 squared part is easy. That's going to give me 25. When I square this -3 root 2, watch what happens. We've done this before, but I just want to kind of refresh your memory. If I take -3 root 2 and I multiply it by -3 root 2, that's what I'm going to do here, right? Let's look at what happens here. Well, that's going to be -3 times -3 times square root 2 times square root 2. And so all I did there is I reordered the 4 things that are getting multiplied here, because that's a -3 times the square root of 2 times a -3 times the square root of 2. So I just put them in this order, -3 times -3, square root 2 times square root 2. And I can do that because multiplication is commutative, which means that we can change the order around any way we want, and we won't change the result. So now I'll have -3 times -3, which is 9, square root 2 times square root 2, which is 2. So I got 9 times 2 plus 25. Does it equal 49? 9 times 2 is 18. 18 plus 25. Does that equal 49? And the answer is no, because 18 plus 25 is 43. So therefore, -3 root 2, 5 is not on circle Q. Let's do another one like that last one that we just did. So we have a circle with a center at 2, 4. So center is no longer at the origin. Its radius is 3 root 3. And we have to check and see if the point 6, 3 is on the circle. So we're going to start off by writing out our template for the equation of a circle. I'm going to look at this and say that's h, that's k, and that's r. And now I'm going to write the actual equation. It's going to be x minus 2 quantity squared plus y minus 4 quantity squared equals 3 root 3 squared. Now let's clean up this part right here. Let's figure out what 3 root 3 squared is. So 3 root 3 squared, let's just do it off to the side. That means 3 times the square root of 3 times 3 times the square root of 3. And so that's going to be 3 times 3 times square root 3 times square root 3. So that's 9 times 3, which is 27. So my equation for this circle says x minus 2 quantity squared plus y minus 4 quantity squared equals 27. And now I know that every point that's actually on this circle, when I put its x and y coordinates in for this x and this y, I should get 27 on this side of the equation. Because I got 27 over here, I should get 27 over here when I put 6 and 3 in for x and y, if that's actually on the circle. So let's go ahead and check that. Let's do 6 minus 2 squared plus 3 minus 4 squared and check to see if that equals 27. So that will be 4 squared plus negative 1 squared. Does it equal 27? 4 squared is 16. Negative 1 squared is 1. 16 plus 1 does not equal 27, right? That's 17. So again, our answer is no, not on the circle.